Spark SQL. This supports SQL operations based on the Spark core. It can easily include SQL queries into Spark programs, and it's programmed in Java, Scala, Python, and R. Programmers can connect to any data source, which is so convenient, the same way and easily join data sets across these different data source types, which is wonderful. Schema RDD-based data abstraction is used, and it provides data abstraction based on data frames. It provides support for structured and semi-structured data, which is so important. It provides DSL, domain-specific language in Scala, Java, or Python, to manipulate data frames. Business intelligence tools can be easily used as the server mode provides industry-standard JDBC and ODBC connectivity. What does that mean? Just wait, I'll explain it to you soon. Programmers can connect to any data source the same way and easily join data sets across different data source types. In order to understand Spark SQL operations, we need to look into some additional terminology. A data set is a distributed collection of data. It is an interface of Spark that provides RDD and Spark SQL functionality. It's constructed from JVM objects and processed using transformations. A data frame is a data set organized into named columns. It's similar to a R or Python-based data frame or RDB, relational database table. I will explain more on relational databases soon. Data frames are created from structured data files, tables in Hive, external databases, and existing RDDs. Data abstraction is a reducing process to obtain a simplified representation of the whole data set. ODBC is Open Database Connectivity. It is a standard API to access database management systems. API is designed to be independent of the database system and the operating system. JDBC stands for Java Database Connectivity. It is a Java API used for client access to databases. It is a Java Standard Edition platform-based API, and it enables database query and update functionality. Spark GraphX. GraphX is a distributed graph processing framework. It was originally developed by UC Berkeley's AmpLab and Databricks. It was later donated to the Apache Software Foundation and the Spark project. It examines the entire graph of a batch process to derive the optimal solution and answer. Graph Computation API is provided through GraphX, and optimized runtime processing of user-defined graphs are enabled through GraphX in Spark. Spark's distributed graph processing framework is based on, of course, its RDDs. Since RDDs are immutable, GraphX graphs are immutable also. GraphX is unsuitable for database graphs that need to be updated. This is because it is immutable. This is because the RDD is immutable. So if changes are made to GraphX values or structure, a new graph will be created. Some programmers use graph database technology with Spark GraphX, and I will explain more on relational databases and graph databases soon. Spark's distributed graph processing framework is based on the RDDs, as I mentioned before, where the entire graph of the RDD is transformed into a combination of vertex RDDs and edge RDDs. Vertex RDDs and edge RDDs are suitable for graph computation and easy to apply graph optimization algorithms. Spark's distributed graph processing framework is based on the RDDs where the APIs enable implementation of massively parallel algorithms and MapReduce style APIs and Prejel APIs. Prejel API enables message sending computation based on vertex attributes and constraint messages on the graph structure. It enables more efficient distributed execution and flexibility in graph-based computations, and provides database abstraction in graph form. These are the references that I use, and I recommend them to you. Thank you.